All right. There are 8 letter tiles in a bag. The tiles are labeled with the letters S to Z. Rachel randomly selects a tile from the bag. Define the sample space. What are the possible letters, like what are possible outcomes in the sample space? She could have S, T, U, V, W, X, Y, Z. Okay. What is the probability of selecting a tile with a particular letter? So let's pick a letter. What is the probability of selecting a tile with the letter V? Well, V, there's one V option out of 8 letter tiles. Okay. So let's construct the probability distribution model. What's the probability that you can choose an S? 1 out of 8. What about T? 1 out of 8. What about U? 1 out of 8. V, W, X, Y, and Z. So if they all have the same probability, we would call this a uniform distribution. All right, sorry, probability model, right? So we can take that information and we can put it into a bar graph. And the uniform one's really easy because they're all going to be 1/8, right? So S, T, U, V, W, X, Y, and Z. Now, remember, this is a bar graph because S, T, U, V, W, X, Y, and Z are not numerical. They are letters. So we have to do a bar graph. And remember, in a bar graph, your bars do not touch. Okay. All right. A number is chosen at random from the list 1, 4, 7, 12, 21, 25, 38, 40, 45, and 48. What kind of probability model describes this situation and why? It should be uniform probability model because each number has an equal chance of being selected. So if each number has an equal chance of being selected, what is the probability of choosing the number 25? Well, remember, probability is favorable outcomes. So how often can the number 25 be chosen? Once out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of choosing 25 is 1 out of 10. Okay. Now let's say that T is the event of choosing a number that is a multiple of 3. List all the outcomes favorable to event T. Okay. List means you can just write it. You can also write T equals, what are the possible multiples of 3? 1? No. 4? No. 7? No. 12? 21? 25? 38? 40? 45? And 48. What is the probability of event T? And we'll write it. So the probability of event T is the total possible outcome or probable outcomes favorable to event T, which is 4. And there are 10 numbers. Right? And we can simplify this down to 4/10. And if we want to write it as probability, if they task us to write it as percentage, we will write it as percentage. Okay? There are 10 herbal tea bags of assorted flavors in a jar. 4 peppermint, 2 raspberry, 3 chamomile, and 1 blackberry. Suppose you randomly pick a tea bag from the jar and note the flavor, meaning you write it down. Define the sample space. So the sample space equals 4 peppermint, which you can either write peppermint 4 times or you can write 4 peppermint knowing that there are 4 of those. 2 raspberry, 3 chamomile, and 1 blackberry. Every time I think of blackberry, I think of the phone. All right. So what is the probability of picking a raspberry tea bag? Well, the probability of raspberry, we have 2 raspberries out of 10 tea bags, which is 2/10 or 20%. So we're going to construct the probability model of picking a tea bag, then use a bar graph to represent the probability distribution. When we're writing the probability in a table, you can do percent or you can do decibels. It really doesn't matter unless they specify whether they want decimals or percentages. Um, both are the same. So um, the probability of peppermint is 4 out of 10, which is 4/10. Raspberry we just did, which is 0.2 or 20%. I'm going to write that underneath. 40%, 20%. Chamomile is 3 out of 10, which is 3/10 or 30%. And blackberry is 1 out of 10, which is 1/10 or 10%. What do you notice about all of our probabilities? They should add up to 1 or 100%. And 40 plus 20 plus 30 plus 10 is 100%. And then we can draw a bar graph. Okay. For probability, you again can use percentage or you can use decimals. Really doesn't matter. So if you want to do percentages, you can do that. Or you can do um, decimals. And now it's a bar graph, so remember our bars don't touch. Peppermint was 40%. Raspberry was 20%. Chamomile was 30%. And blackberry was, oops, 1%. Okay. So looking at that table, it's so much easier to be able to read, right? Not at the table, but the graph. I can see that peppermint is more likely, has a higher percentage, has a higher probability of being chosen, while blackberry has a less, least likely percent to be chosen. Okay. All right, 9 cards are made from each of the letters from the word beginning. You select a card at random. Find the probability of getting a letter N. Well, N happens 3 times in this word, and there are 9 letters. So the probability of getting N, so I'm going to say the probability of N is 3 out of 9, which simplifies to 1/3. We're going to do a probability model for all the letters. So we're looking at B. How many times is the letter B in the word beginning? Once. 1 out of 9. Remember, 9 does not divide evenly, so we're going to leave it as a fraction. How many times is E? 1 out of 9. G, we have 2. I, we also have 2. And N we already did, which was 3/9, which equals 1/3. What is the probability of selecting a card with a consonant? So consonants are anything that's not a vowel. So what letters in the word beginning are consonants? B, G, and N. So if B, G, and N are our consonants, the probability of selecting a card with a consonant, we're going to add all of these numbers. So the probability of a consonant is 1/9 plus 2/9 plus 3/9, which is 6/9, which simplifies to 2/3. So the probability of selecting a card with a consonant is 2/3. All right. Your homework is page 286, number 5, which is the last try, which follows, it's an example of doing the uh, same as the like baseball player heights one, so information from a table. And then page 287 to 290, 1 to 7.